Hello, welcome to PhyzQuest. So this is the solution video for CSIR NET December 2019 Part C, question number 8. So question number 8 is, in a spectrum resulting from Raman scattering, let IR denote the intensity of Rayleigh scattering and IS and IAS denote the most intense Stokes line and the most intense anti-Stokes line respectively. And we need to find out the correct order of these intensities. So let's get started. So this question comes from the section Atomic and Molecular Physics, and the concept involved here is Raman scattering. So to answer this question, we have to understand what is a Raman scattering. Raman scattering is the inelastic scattering of light by any kind of matter. The light source used here is a laser beam. So when a laser light or laser beam is incident on the matter, the photon from the laser beam interact with the electron in the sample. So the electron absorbs the energy of the photon and goes to a virtual state. Now since it is a virtual state, it is not a stable state. Therefore electron comes back to the original ground state, emitting the photon back. Now based on the energy of the incident radiation and the emitted radiation, there will be three different scenarios. Now before that, you should understand that in a ground state, it supports a large number of vibrational energy levels or vibrational states, and the lowest level is the original ground state. So here, out of the three scenarios, the first scenario will be electron, as you can see here in this image, electron in the original ground state, after absorbing the photon energy, goes to the virtual state and comes back to the same state by emitting the photon. So here there will be no change in energy of the photon. So this scenario will be called as the Rayleigh scattering. Second scenario will be electron from the original ground state goes to the virtual state and comes back to one of the higher vibrational level of the ground state. This means here electron has absorbed certain amount of energy from the incident photon. Therefore the emitted photon has the lower energy than the incident photon, and this is known as Raman scattering, and the type is called Stokes line. And the third scenario will be electron is excited from one of the higher vibrational level of the ground state to the virtual state and comes back to the original ground state. This means here electron has lost some of its energy. Therefore the emitted photon has more energy than the incident photon, and this is another type of Raman scattering called the anti-Stokes line. The question here is about comparing the intensities of the three types of the scattered radiation. Let us name the radiation. The Rayleigh scattering intensity is IR, Raman scattering Stokes line is IS, and the anti-Stokes line intensity is IAS, which is mentioned in the question. Now by definition, intensity is the total energy falling on a surface per unit area per unit time. Now the total energy depends on the number of photon as well as the energy of each photon. This completely depends on the scattering process. In case of Rayleigh scattering, electron gets excited from the ground state and comes back to its original state. So there is no involvement of any higher vibrational level. Therefore this is the most common type of scattering that can occur. Therefore the intensity of Rayleigh scattering line will be the most. Now if we talk about the Raman scattering, here electron is excited from the original ground state but comes back to the higher vibrational level. Now in this scenario, if you compare with the Rayleigh scattering, this will be has a less possibility as compared to the previous one, because coming back to the original ground state has higher probability than coming back to a higher vibrational level. Therefore, the intensity of Raman scattering will be less than the Rayleigh scattering. I'm talking about the Stokes line. So Stokes line has the less intensity as compared to Rayleigh scattering. Next, when we talk about the anti-Stokes line. Now, anti-Stokes line here, the electron, this needs that the electron should already be in a higher vibrational level. So the possibility of electron to be already in a higher vibrational level is very less, and due to this reason, anti-Stokes line will have the least intensity. So finally, if you write down the sequence here, IR is greater than IS is greater than IAS. Now let's check the option. If you look at the option, you can see that option B is matching with our result. So the correct answer for this question is option B.